So, I hear everybody is rushing to the public cloud nowadays. But should they? I don't think so. Wanna hear why? Stick around. Alright, so here's the deal. You're a software developer and you want a new Linux up and running somewhere for your testing purposes, whatever your purposes might be. What is the easiest way nowadays to do that? Using a virtual machine. So we want to have a virtual machine for this purpose. And while in modern world, it might in many cases seem like a not very complex task to spin up a virtual machine, if we really peek a little bit closer, take a look behind the curtains, we will see that there's much more to it than just a virtual machine hanging in thin air. Just like a thousands of years old Chinese saying says, where there's a virtual machine, there must be a server. So we must have a server running this poor virtual machine. And what I mean by running the virtual machine, I mean that virtual machine is a software. And what the software needs is a hardware, a computer that has a processor and some memory capacity. That's what we need. A third component that we need some place where we store the data, where we store the virtual machine data itself. So we have to store the data somewhere. In enterprise environments, most of the time, what we are using is something we call storage array. So we have our storage device here. Now we have virtual machine running on a server, virtual machine data stored on a storage array, and then we still need one component here in between. We need some kind of a device to connect these two together. And that fabric in between we call storage array network. So we have a special dedicated network for connecting servers to storage devices. We still need another kind of network. We need a network connecting our server to outside world. And that is our Ethernet network there. Now, this is now containing all the basic elements what we have in a data center. However, in enterprise environments, we are pretty skeptical people. We really don't trust in any of these components to function perfectly. And funny thing is, not even vendors are very confident in their own products. You cannot find one single server vendor that says that you are just fine with one server in your business critical production environment. They are always recommending at least 2 of them for redundancy purposes. So what we need to do still in this picture is we have to duplicate everything. And then obviously we want to cross-connect them. In case one of the switches break down, we still have a path to our servers. In case one of the fabric switches break down, we still have a path to our data storage devices. Now, one more thing in the picture. In modern implementations, data centers, we are clustering our servers using special software, clustering software. So clustering means connecting similar kind of servers, running similar workloads together so that they can work together as a bigger system, so to speak. This clustering of servers, these were my servers, are clustered nowadays together using a hypervisor software. Hypervisor is not only clustering host servers together, but it's also running the virtual machines and taking care of migrating virtual machines from one server to another server in case of maintenance or hardware failure or something like that. And this is how most of the private data centers are nowadays implemented. This is how they most of the time look like. Of course, we will have many more servers. We probably have many more storage devices and so on and so on. But those are the basic components. So what happened here? I just wanted to spin up a simple virtual machine. I just needed it for my testing purposes, and all of a sudden the picture looks like that. I don't want any of that. I just want my virtual machine. I don't, this looks too complicated. And quite honestly, for many companies it is, because most companies just want to focus on their core businesses. They don't want to take care of any of this IT complexity. And that is the sole reason why public cloud is so popular nowadays. Where do I write it? Right there. So let's take a look at an example how this would happen in a public cloud. So what we have there is some nice, clean and simple user interface where we have a couple of sliders. 1, 2, 3 for simplicity. 1 for selecting how much processor capacity we want, how much memory we want for the virtual machine, and how much network bandwidth. Then we want to have a OK button here. And once we click that OK button, we will have our virtual machine magically up and running somewhere. And this is all we see. We go to user interface, choose what kind of virtual machine we want, click OK, bam, it's up and running for us to use. So this is how public cloud works. And that's what's appealing to end customers. I don't have to worry about any of that complexity. All of that is hidden from me. But once again, let me repeat myself. Where there is a virtual machine, there must be a server. So when we take a closer look behind the scenes in the public cloud, we see that actually there are all the same components present than in the left-hand side picture. There's only two differences. One being we have this. Here, if you want to provision a new virtual machine, you have to go and talk to some service owners, network guys, storage guys, and all those guys need to work together to provision some capacity here and dedicate some network bandwidth for you to have your virtual machine up and running here. While here, you go to user interface, hit OK, and all that magically happens in the background automatically, and then you have your virtual machine up and running. The second big difference here is very important. Here, this is your private data center. You own this. This is yours 100%. This is somebody else's data center. It's not yours. Somebody else is maintaining it. Let me ask you a question. So we have the important data here. That data is the most crucial data to your company. It's the competitive edge that you have over the competition. So this data, which most companies have, is something we really want to have close to us. We really want to protect it. We really want to be able to use it when we want to use it, but we want to be absolutely sure that nobody else has access to that data than us. Here, it's simple. But are you really ready to take your data here in a private environment and give it to somebody else? Here, take it. Keep it safe. Keep it secret. Keep it safe. But you have to promise to me that you will not peek into that data. At no times, you're not allowed to take a look what's in that data. Now, while I'm not saying that any of these public cloud service providers are actually looking at your data, most probably they are not. But there's no way of knowing for sure who has access to that data, especially when you have to prove it to some other authority. You have to meet some compliances like GDPRs, HIPAAs, SARPS, Oxleys, whatever these regulations you have to take care of. How do you prove that nobody else has access to that data but your employees when that data is taken care of a third-party public cloud? You don't know any of the employees' names that are working in the data center day to day, and so on and so on. So security, ownership of your precious data is one of the biggest problems what people are having in public clouds. So that got me thinking, if there would be a way for me as a company to have security like this, so that I would at all times know what's happening in my data center, who has access to that data and when it's being accessed. But at the same time, I could provide my end users this easiness of public cloud, because I know they love this. They absolutely love this. So let's just have this with this. What we now have is the privacy that we have here combined with the cloud aspect that we have on the right hand side. This way we can easily, using simple user interface, provision our virtual machines up and running within seconds or minutes, while having complete visibility to what's happening in our environment. Now, there are many ways how you can actually construct this private cloud, and there are many foundational elements that are better to choose from than something else. Traditional data center components that were designed 30 years ago to support the world back then are maybe not the most ideal ones. There are new emerging architectures that are ideal for private cloud. One of my favorite topics is hyperconvergence, and that is something that I will be dealing with the next video. So let's continue the story with the next video about private cloud. Thanks very much. If you liked it, like. If you want more of these, subscribe.